Module 25 Non-parametric tests, Section 3, choosing between parametric and non-parametric tests. So there are several issues with non-parametric methods. What are these issues? So the main issue is with the statistical power that tend to be quite low if the distribution is non-Gaussian, but it's quite powerful if the data is data is indeed non-Gaussian. It is powerful. Non-parametric method is powerful, but if the data is Gaussian, that is if the data is normally distributed, then statistical power is quite low, and this is more apparent when the sample size is low. So if the sample size is very high, then there is no problem with that, but if the sample size is quite low, this apparent problem with the statistical power is very dominant. So another main issue is that there is no confidence interval with the non-parametric test. So confidence intervals are very essential. I would say that it's much better than the p-value. So unfortunately, you cannot calculate the CI with non-parametric methods. And there is no regression method, so you cannot do that regression with non-parametric methods. So that is yet another problem with the non-parametric methods. So how do you choose? Is it parametric or non-parametric? So if the sample size is really large, then for Gaussian as well as for non-Gaussian, both methods have identical power. So if the sample size is large, you can either go with the parametric or with non-parametric for both Gaussian and non-Gaussian. So perhaps parametric method is preferred because parametric method can also calculate the CI, and it is both are equally powerful for detecting, the statistical power is quite high. Now the problem is with if the sample size is small. So what is the problem? The distribution is very, very important. So if the sample size is low, the distribution, it depends on the distribution. If the distribution is non-Gaussian, try for transforming to the Gaussian first. So rather than going for a non-parametric test, it's always better to transform to the Gaussian. For example, from the log normal transformation, or reciprocal transformation, you can do that. Try it out. Does it work or not? And you can try to remove outliers, not by randomly picking. Subjective interpretation is wrong. Paranoia, which I told you earlier. So you can perform a route test or Grubbs method for that. So if nothing works, go with non-parametric test. So the choice should not be automatic, just go directly with the non-parametric. No, it's always better to look for the transformation to the Gaussian first. So how about normality tests? So normality tests are meaningful only if the sample size is large. Now for large sample size, that means large in the sense thumb rule is around 48 or more in each of the group, both methods are powerful and robust. So there is no point in going for a normality test. So it's rarely useful, the K2 omnibus test, for example, but because it's useful only for the large samples. So what is the sample size for the non-parametric test? The general rule of thumb is that 15% more sample than equivalent parametric test. So I have already discussed how to calculate the sample for parametric test in module number 15. So calculate that and then add 15% more for non-parametric test. So there are some minimum requirement. For example, Madden-Whitney U-test need 8 samples or more, while Wilcoxon-signed rank test needs 6 paired observations. Kruskal-Wallis test need 5 elements in each of the group. See, Kruskal-Wallis is analogous to ANOVA. So each group need 5 elements or more for this test to work. And Spearman's correlation need more than 5 XY pairs. So these are the minimum requirements. So in summary, a major issue with non-parametric test is that it's less powerful when the distribution is Gaussian for small sample. For large sample, size like 48 or more in each group, both methods are equally powerful and robust. A general rule of the thumb is to add 35% more samples than what is required for the parametric tests. Thank you so much.